Alright, this is the second video, and actually from the first video I was wrong. This is the regiebot 2.0. The 1.0 got pretty much scrapped because I couldn't fit all of the parts into the little tiny robot I wanted to put it in. The battery was a little too large and other problems. So we'll go through and explain the circuit a little bit better. This is pretty much a finished hardware version. You can see there's some changes. I mounted the ground effects LEDs on the board itself because so I could clean up some of the mess and stuff like that. The switch, everything's mounted in. It's pretty much ready to go, and put the cap on it. I'll explain this a little better. This is a Pickaxe 20X2, a Texas Instruments H bridge. I've got a 5-volt regulator, a linear 5-volt regulator. And you see the jumpers here. These are the connections from the PIC to the H bridge, and I like to put jumpers on. I put these on in this case because quite often I like changing the way the H bridge is set up. Sometimes I'll use A and C or D and A for the motor connections in my programming instead of using them conventionally with A, B, C, and D. It just works out a little better, and sometimes I like changing it, so I went ahead and put some jumpers on. We'll pull this apart here and take a look at the bottom board. You can see here, this is where all the magic happens. These are all the connections. All the resistors and everything have been done in surface mount, the resistors and small caps. It was pretty easy. I bought a resistor pack for about $4 that had about 50 or 25 of each with 97 values, and it was a lot easier than doing the through-hole stuff and trying to modify and change things in order to make sure you got the parts, or running down to the store, 2 or 3 times. I just had everything I needed. The soldering was pretty simple. I went through the tutorial on SparkFun, SparkFun.com's website about doing the surface mount, and actually figured out and learned some ways of doing it myself. You can see the board's built here in 2 separate parts, a lot like the Arduinos are. So it's pretty much just plug and play, and boom, you're in business, and make sure both sides are plugged in. And you can see here in the back I've got, or for the power, I'll explain that. It came with a battery pack already molded in plastic with 4 AA's, which worked out. I just unsoldered the board and soldered a couple leads onto it. And the same thing, I went ahead and hacked off the motor connectors to put them on the board that came with it. And you see the battery pack, it's just 4 AA's, so it gave me 6 volts. It was perfect. And I've got the switch mounted in the back here with a little perforated board. I just went ahead and soldered it together and mounted it, and I've got my programming dongle sticking out here with my serial in, serial out, and ground. Makes it pretty easy to access when the chassis is all put together and the caps, the tops on it. We'll go ahead and stick our PIR on here, and you can see I've just pretty much got a 3-pin connector and a little 3-pin that's sticking up here. We'll go ahead and plug that sucker on there, and we'll set this on the back for now. We're going to go ahead and download a debugging program for it and see how that works out. So I got my programmer over here. You can see I pretty much just took an audio jack that I got from SparkFun and a board and soldered 2 sets of male pins on it so I could stick it on the breadboard or use it somewhere else like this. And I made up a little dongle that goes in between because quite often when I work on projects I forget which directions I put the serial lines in. So I just make a dongle for each one, or just move the other one around, or an old one. So go ahead and flip this over here real quick and plug this thing in, and hope we got it in the right direction. It's kind of 50-50, so. There we go. Now it's plugged in. We'll go ahead and set this back on our tape roll here so we can have the motor run. Set this PIR up backwards and point it away from me. Okay, now we'll go over here and take a look at the computer. You can see I'm got a FTDI chip, which is the little pickaxe programmer from SparkFun. It comes with the audio mount. I just threw some shrink tube over it, and you could see the board. I've actually got some other ones of these coming in. I'm waiting on the boards from batch PCB. It's hooked up into the computer here, and you can see we've got a basic debugger program. This is going to look for the input going high on the PIR. If it does, it's going to go to subroutine, which is going to turn an LED that's hooked up on and back off, and then go back and go for a loop. This is a basic debug program for the PIR. Let's go ahead and turn this thing on. Now it's on. Then we'll go on ahead here and hit our program button. It says downloading program, so we get the cable plugged in right. This program I'm using is AxePad. Download successful. We'll go ahead and take a look here, and the program should be running. And inside you'll see there's a blue LED. Should go off. And that's the LED output from the PIR. And I found out if you let the PIR sit for about 10 to 30 seconds after it's turned off, it has a little better and more accurate result. I had some problems with it working at the beginning, so. And it's not wanting to work now. There it is. And you can see it functioning. It's pretty much the best example I could give you for working with the programming. Go through and build little debugging programs like this, and get everything working piece by piece. And you'll end up having all the pieces, and then the fun is canning and putting it all together. That's pretty much it. I'll give you a look around here. This is the body, cigarette butts, laptop, cans of Rockstar, empty beer bottles, and then you can see my desk here. It's a mess after the project. Everything's all torn apart, and that's pretty much it. And if you want to look at anything else, take a look at sparkfun.com. They've got lots of fun tutorials and stuff on doing the surface mount and other stuff. And take a look at the Arduinos. They're fairly simple to use, just like this. I like the pickaxes because you can pretty much pop a resonator on the end of them, and they'll start smoking, and you get some pretty fast programming speeds, although the chips aren't very expandable. But anything else, like I said, take a look. The Arduinos, they're fun projects, and keep in touch and take a look back, and I'll have some finished videos of this thing running.